Look, this is a very interesting pump. The crescent-shaped cavity inside moves constantly during rotation. The slider also follows in and out of its own track. His name is Xuanpian pump, sliding vane pump or vane pump. The reason why this wonderful phenomenon occurs? 2-point eccentricity and centrifugal force are indispensable. That is, the centers of the circular rotor and the circular cavity are not at one point. Because the blades can slide freely, so under the action of centrifugal force, the blades can always be in contact with the cavity wall. Of course, if you are worried that the centrifugal force is not enough, it is also possible to install a spring in the drill slot. For example, this simplest rotary vane pump. Let's use it to analyze the working principle of the pump. First, due to the obstruction of the blades, we can divide the crescent into 3 parts. ABC, when the rotor rotates clockwise, the volume of space A is gradually increasing. The gas pressure decreases because it is connected to the suction port. So once the external pressure is greater than the pressure inside space A, only inhale the gas at the same time. The volume of space B is gradually decreasing. The gas will be continuously compressed, finally connected to the exhaust port, so we reach the position of space C. When the pressure of this part of the gas exceeds the exhaust pressure, the exhaust valve will be pushed open. The gas passes through the oil layer in the tank and is carried away. People also connect the 2 pumps together, a double ridge pump. Now let's go back to the beginning and look at the original Xuanpian pump. Is it much easier to understand? In short, they all achieve medium transportation by changing the solvent. There is also a more complex double-acting rotary vane pump. Note that its nail and rotor are concentric, and the shape of the nail cavity is no longer round. Instead, it is composed of 2 long radius arcs, 2 short radius arcs, and 4 transition curves. He can complete 2 inhalation and exhalation actions in each rotation. Because the oil suction area and the oil pressure area are competitive and symmetrical. Therefore, the hydraulic pressure acting on the rotor is balanced. This allows the pump to run more smoothly. Reduced energy loss.